Okay, so my name is Dr. Sam Jensen, and so this is Chemistry 111. And so in this particular course, everything is going to be virtual. So we have lecture pretty much every night because we don't have the issues of having lab that are usually would normally take up part of our time. Again, part of the course being 6 to 9 is not going to actually go 6 to 9. It's very rare that any of these lectures will go more than an hour and a half if I can help it, because again, we have 4 nights a week, and I mean, I made it through the spring semester of 2 nights a week and not had to go, it didn't have to go more than an hour and a half at a time for most of the time. We do have a bunch of labs. I've done a bunch of work to try and put some of the labs together for the summer that are all virtual, but there are some where there are some simulator stuff. So you can have access to a simulator and you're kind of being able to kind of put stuff together and move stuff around and play with some of the setups, very similar to as you would if you were in class, okay? So it is Monday night, and we would normally have a lab. Lab is Monday and Wednesday, and then lecture is Tuesday and Thursday. But again, those things are kind of out the window at this point. All right. The class is very full, so we have like 32 people in the class, and normally my classes are only capped at 28, but we continue to add more people as the day goes on. So that doesn't really impact much of anything other than grading when I get to that point. So it's just a matter of getting everything in on time. If everyone is getting assignments in on time, which everything is submitted on the Canvas site, so you don't need to email me stuff, and everything should be paced out. Again, this is a very fast class. It's only 6 weeks. So you don't have any time for really being late with things. So, because by the time that you're already late with something, we've already moved on. Okay. So I will have office hours, or I'll put an office hour thing that basically I'll start class a little early every day. And then again, you can log in early if you wish to talk. You have particular issues with things. And I mean, really there's lots of things that are going to be a lot more lenient, and we have to kind of work our way through it, but there's nothing functionally different of this course than any other summer course that I've taught or any of the spring or fall semester. Okay. So you're still getting the full show. It's just a matter of that we don't have to go to class to do it. Okay. So I have been teaching here since 2008. I have a bachelor's and master's in chemistry, and my PhD is in biodefense. And so I have been teaching chemistry since about 2001 when I was in grad school. So I've been doing this for quite a while. I've done just about every kind of chemistry that you can do. I've worked for small little labs up to big labs making thousands of gallons of chemicals. I've done all different kinds of chemistry: analytical, synthetic organic, materials chemistry, polymer chemistry, fuels, all kinds of stuff, explosives, anything that you can think of, I've probably done at least some portion of it at some point. So I am not a full-time faculty member here. This is my part-time job that I do on top of being a real scientist. So I do work for the military doing science. And so I'm a science advisor during the day. And so I pretty much now sit here in my office pretty much all day long. And now I will be here even longer for class. But I basically help other people do better science. And so I manage science, and I manage other scientists, and I manage you guys. And so pretty much my entire day revolves around being a scientist and doing this kind of work. Okay. So a lot of the coursework, and I can already see some of the information on this slide is a little bit moot. But I had changed around a lot of my coursework in the spring. I had redesigned the entire course. I put everything back to square one. I started over again with things like focusing on specific learning objectives. And so you're going to see in the beginning of every chapter, there are very specific learning objectives that I want you to be able to walk away from. And so those learning objectives are geared towards, those are the kinds of questions that I'm going to ask you on the test, to test against those learning objectives. Okay, so the learning objectives are not, understanding things, because the question then becomes, how do I test understanding? How do I test whether you understand how to do something? So the learning objectives are very specific, like you should be able to do calculations. You should be able to convert units in the metric system. And so when I ask you a question that is about metric system conversion, it's focusing on that specific learning objective. Okay, so the material is mostly all new. Again, this is not, this course is not meant to be taught virtually. This is not the ELI class, but it's better in some ways because you guys have lecture with me every night, whereas the ELI doesn't really have the same kind of setup where they have a giving lecture. They basically, it's mostly teaching yourself kind of stuff. So that's all the online people. But, and so the one bullet here on the flipped classroom thing, again, that was kind of something that I was doing in the spring semester, was more of like, the flipped classroom method is where instead of lecturing, I gave a video on the lecture material, and then we worked practice problems in class. And so it was, instead of you doing practice problems at home and then coming to class for a lecture, we did it the reverse. And so I had one of the chapters was set up as a flipped classroom, which now, again, doesn't work. So as we go through the virtual dynamics here, if there's stuff that you find missing or is not accessible on the Canvas site, or there's material that you need, or I'm not covering something well enough, again, we have time to work out problems in class. So it's what I've also set up to is a YouTube channel. So I post my stuff to my YouTube channel. So I've been doing practice problems, and because it's hard to do, because I have this one camera right on the screen here. So the question is, how do I do practice problems? And so we kind of found a workaround where I can use my phone, and I call my phone logs into the meeting, and I use my phone as a second camera. And then I have a tripod that I set up, and then I set my phone there, and then you guys can kind of see as I kind of scribble underneath it and things like that. So we kind of made like a workaround, but it's not optimal. It's not like having a chalkboard. So I don't have access to that kind of thing, which is a little easier for us to do things like practice problems in class. I usually spend a lot of time doing practice problems, but it's a little harder in this kind of setup. Also because my phone is older and it's not meant for like being on and recording for an hour-long class, and so it overheats and things like that. And so I've been trying to do shorter 10, 15-minute videos on various practice problems in the various chapters. So you will see probably other lecture videos that I used from the spring. Again, I will be updating some of those, doing some new ones. Again, we didn't start doing the virtual stuff until about midway through the spring semester. So yeah, just want someone else trying to. So we didn't, so some of the material you'll see videos of me start showing up in some of the later chapters, whereas they're not there in the earlier chapters. And so this is where some of these videos will show up in there as I do some of these, okay? But I am passionate about education. I love teaching, and I love doing chemistry and helping people with science. And so it's a big function of the stuff that I do all the time. All right, so we'll see how much of this is not pertinent now. So obviously chemistry is not easy, right? So it does require a fair bit of work, especially now, and especially because it's a 6-week class. So we really don't have time for lackadaisical pace. It's pretty fast every day. We'll probably be into some new chapter almost daily, almost. So it's almost a lecture or two per chapter. And then so by in a week, we're basically covering a chapter or 2 chapters in a week, basically, almost. So we'll try and have, so that's where, because we have so much extra time, I don't really need to spend a whole lecture. So we're not going to be here till 9 o'clock ever. I would say probably an hour and a half is probably at most how long we'll really need to go. Stuff that you guys turn in, I will have graded and turned around to you. So everything you'll see on the Canvas site, you will have access to fairly quickly. One thing that you'll find here is that, again, I don't teach by a particular book. And we'll talk about the book here in just a minute. Okay, so I don't teach by the book. So I'm not reading out of a book. I don't have a particular book that I use. I mean, I have my book that I use, but it may or may not be the same book that you use. But my course is set up that it doesn't matter which book you have. Okay, so again, you can buy an expensive book or you can buy a cheap book, and both books will work. Okay. So in real life, I mean, chemistry is applicable to us all the time. There's all kinds of chemistry to be found everywhere. There's all kinds of science to be found everywhere. And looking at analyzing complex problems, being able to organize information, looking at patterns and data analysis, and being able to improve our problem solving skills. Okay. So, I mean, these are practical skills, our critical thinking skills that we use all the time, or that we should be using all the time, to where it becomes second nature to us. Now, while we may never use the elementary chemical problems, macro scale stuff we use all the time, as well as some of the writing skills. So usually in most semesters, there's a bunch of writing to do. Okay, so in the summer, it's tailored down. So we don't have a research paper to do, which is about the only thing that I cut back out of the course. There's no research paper. During a regular semester, we do have a research paper. We will look at journal articles. Again, there's 2 journal article assignments that we'll look at. So that will require you to find journal articles, or find the journal articles I've given you. So there's a little bit of a challenge there in using the library, okay, to find the actual journal article. And we'll talk about that later. I'll give you a whole tutorial on how to find stuff, okay? But working on our critical thinking and working on our writing skills are skills that we'll use every day, that we should employ all the time, regardless of whether or not we do any further science. Okay, so again, a lot of this is more pertinent to when we're actually in the class. Obviously, if you miss a class, I'm going to record the classes, so there will be recordings of the class. They may not be right away, like, may not be show up like an hour after class. I will try and get things loaded as quickly as possible, but it's, I'm not really great with getting all the video things to work. And they also actually just changed the Zoom thing like 2 days ago, which I was extremely pissed about, because there's like some features I already had set up and everything, and now they've changed it. So it's a little frustrating. So they are trying to throw a wrench in my system already, and I'm not really great with technology, so it's a little frustrating, but we will get the videos loaded. So, but you do have to take care of yourself. So if there's things that become overwhelming, you need to do the dropping. Okay. I don't do paperwork. Okay. So if at the end of the semester you find out that you weren't dropped from the class, it's because you didn't do the paperwork. So I'm not doing any paperwork other than the grading that I already have to do. Okay. Again, assignments, we don't really have a whole lot of time. It's 6 weeks. There's going to be We're going to be banging out stuff pretty much every week. There's going to be stuff, whether it's a test or assignments that are due all the time and the labs. So you're going to have, it's going to be a quick pace. So there's going to be stuff that's going to be due all the time. And more than likely, I'm probably not going to remind you all the time of things that are due, because honestly, I will probably forget what assignments are due when, just because I'll lose track of time. But you guys will have to keep track of what stuff is due. So there will be due dates. I'll make sure I post up on the main page, like a set of due dates so you can mark it. They also should show up on the calendar too, when things are due. So I think I may or may not have done the labs or not for this class. I did them for the ELI. I'm also teaching ELI. I'll also have another 111 class and a 112 class that I'm doing as well. So I have a lot of things going on at the same time. So I'll make sure that we've got everything set up for this class. All right. So really the best advice is going to be work lots of practice problems. Okay. That's why I'm going to recommend the book and the practice problem solution manual. Working practice problems, it's kind of like a chemistry class. Okay. So you work, or a lot like a math class. So if you work a lot of practice problems, that will help you in doing the tests. Okay. Pulling things from various sources. Again, your textbook, the PowerPoints, whatever textbook you have, you should be reading and doing the practice problems from. All right, so we can come back to the tests here in a second. So let's take a look at the Canvas site here real quick. Hang on, I got. One second. Looks like the one message I got, somebody managed to come in. Like I said, when you do log in, like I said, just use your full name when you do log in. I'm trying to keep track of for what I can. I know there's some sort of attendance thing on here, but you know, I don't. All right. So let's look at the Canvas site. Okay. So everything is mostly organized here. Okay. So so this is kind of everything is organized by chapter, by the areas that we're going to work from. All right. So let's take a look at the syllabus here first. Okay, so obviously you have my email address. I will probably be online a little bit early for every class, so you can log in for any office hour. Oh, okay. So if you can't hear me, just like I said, just chime in because everybody, can you hear me now? Everybody here okay? Yeah, like I said, I work with what we got here. So if there's sometimes the audio breaks out a little bit, that's certainly why I generally do shorter videos so that I can not have to worry about the audio quality. All right, so most of this is boilerplate, regular stuff. So this is the book that the campus uses. Okay, is the Macmillan Interactive Atoms First. Again, this is $98. Okay, this is not the book that I would like to use. Okay, so if you don't want to spend $98, you don't have to spend $98. Okay, this is the book that we had been using in previous semesters. It's called the OpenStax Atoms First book. It is free. Okay, so you can just click on the link. Okay, and let's see if it. Okay, and so this book here, so you can look at the table of contents. And so these are the chapters that we are essentially going to go by. Okay, so you can see the list of the chapters here from the Adams First book are the chapter orders that we're going to go with. Okay, so when I'm talking about chapters, chapter 7, I'm talking about this chapter 7. So if whatever book you have, it's not important. Like I said, you can find these same topics in whatever book it is that you're working from. You just have to, do a little bit of digging to find the information. Okay, but for most textbooks, this is pretty standard, straightforward topics. The only difference is in some older books, especially the ones that I may also recommend here, that they may not be Adams First, and so that means that things like electromagnetic spectrum and periodic properties, those may be later chapter books, maybe later in the chapters. Chemical bonding and stuff like that, and geometry, those may be later chapter stuff. Okay, so that's really your only difference is to focus on. This is a free book. It has practice problems, but a free book is also what you get for it. Okay, so it is free, so that means it's not the best quality that you can get, right? So there are 2 other suggestions here that I have, and I would highly recommend getting the study guide with it. Okay, it can help you solve practice problems. Like I said, this is like a math class, so you got a lot of practice problems to solve, and so having the study guide helps when you don't have a lot of time to wait for answers on how do we do practice problems. Okay. You can probably get these older books, the Tro or the Silverberg book, for under $30. Okay, for both the study guide and the book. Okay, I use the Tro book. I have like the first edition Tro book from like 12 years ago. And that's still the book that I use. Okay, so my book is all beat up now, but I still use the original Tro book from back in the day. You can't even find this thing anymore. So, but it's the same book as this first one. I like the Tro book. The questions are very straightforward. The chapters are well organized, but here I don't think this is an Adams First book, so you have to kind of play with some of the chapter organization if you get one of these other books. Okay, so I would recommend getting one of the other books. Don't pay a lot for it. Okay, they haven't changed hardly anything in these courses other than the chapter order since I've been teaching this class. Okay, so there's no reason to really spend $98 on a book. Okay, this thing comes with a whole bunch of other online resources that I don't use, so it's not worth spending $98 on. Okay, and even if you take the 112 and they make you buy this one later on, there's nothing you can do about that. But at least if you're not taking the second semester of 112, then you can probably avoid that altogether. Okay, so these 2 books with the links here, I think the links still do work, right? And so, so there's the Tro book, and so again, you can find used versions, okay, for relatively cheap. All right. All right, let's see. So the total here is somewhat in order. So we've got most of our labs here. So we've got journal article assignments. So there's a whole bunch of enough of assignments. These are the regular assignments that we do in a regular semester, but we're going to jam them all in there, right? So there's the first chapter is just the quiz of chapter 1. So we just have the quiz of chapter 1. And then we have a nomenclature quiz. All of the quizzes and tests are all online, obviously, which again is not ideal because my test average when people did this normally is around a high 70, and then I did this at the end of the semester, and my hardest test from the spring semester was like hitting like the high 80s and low 90s as far as an average. And so so obviously doing it online is a little easier than doing it in class. Okay, so we have 2 quizzes. So the nomenclature quiz is online. I just set that one up, but then there's 3 tests. Okay, and so the tests are spaced out about every 2 weeks, right? So we got a 6-week class, 3 tests every 2 weeks, and so there's no final. It's not like a final, a cumulative final. It's just the 3 exams, and the 3 exams cover the bulk of the chapters. Okay, I said we'll have lab work. We don't really have class. Hang on, I don't know. Okay, something popped up. I didn't know if someone was. Trying to get in. Sorry, it's a lot of little screens to manage on his thing. All right, so let's see. So I think that takes care of most of the syllabus. Okay, so you can peruse through the syllabus at your leisure.
Professor, I have a question.
Yes, question.
Would one of the exams be dropped or lowest grade or?
Okay, good question. Yeah, no, none of the exams are going to get dropped. It's just a raw score total. So the first test covers in the PowerPoint. The first test has like chapters 2, 3, and 4. Exam 2 is chapter 6 and 7, and then exam 3 is 8 and 9. Okay, and then the first quiz, and then so the first quiz.
Oh, your voice is cutting out.
All right, hang on, let me unplug and plug back in. All right, how are we now?
Yeah, it's good.
Okay. All right, good. All right, so yeah, so the test dropped, kind of included as a raw grade. Let's see. Okay, so we're going to be in number 1 here. Number 1, you'll see set up in each one of the chapters. So just the PowerPoint we'll be going over tonight as well. And then the first chapter is really the unit. And so objectives. So as I said, each chapter has an objective, learning objective on the Canvas site. So the chapter that you see will mirror the learning objectives found on the PowerPoint. Then there are a variety of YouTube videos in there. Again, are extra. I will probably have my own added in here, but again, these are this other who has a great YouTube channel, and so he has practice problems. Things are much better than mine. So I put as many of these in there and for practice problems that you're going to be working over. So every chapter should look similar. And then I also tend to put resources. So there are a variety of other resources for you, things like extra quizzes for chapter, or resources for each section. Okay. So credit kind of comes up as it does. So in the extra section, right? So there is a section for extra, right? Right now, I haven't included there, but in previous semesters, on when it was, so for example, during spring is one day, so I had people write a op-ed. If you're familiar with an op-ed, it's an opinion piece. It's usually submitted to newspaper, usually only like 700 words. They wrote an op-ed on Darwin or the Darwin Day, and so that was extra. There is extra credit built into every test. Okay, so every test. I mean, again, in Canvas, it said it's going to say 108 points the test, but it's actually only 100. So every test has 8 extra credit points built into it. Quiz, you look at the nomenclature quiz on the Canvas site or the grade rubrics that may show up in the grade sheet. It's worth 50 points, but it's actually only worth points. There's 20 extra built into the nomenclature quiz. Okay, so usually the nomenclature quiz is the biggest section that I give for extra credit. So it's 20 extra credit points for the nomenclature. Tests all have it. The nomenclature quiz has extra credit. And then it's just whether or not like there's extra assignments that we can do. With the 6-week class, it's kind of hard. I mean, there's a bunch of labs. There's a bunch of labs we got to do. There's a bunch of the journal assignments we haven't even talked about yet. Whether or not do like an optional op-ed at the end in lieu of a research paper. So you will see the research paper link, but it should say, you know, we're not using this for the summer. So you're not going to use, so any of that stuff in the research paper link is not pertinent for you. Okay. The assignments. So again, we'll spend some time talking about this another time. So there are 2 journal assignments. This is finding and reading a journal and pulling out pertinent details. Okay, so not familiar, if we're not used to journal articles, it's a place to start. It's what is the background information? So it's essentially, you know, looking at, you know, what was the purpose of their research? What did they find? And then some discussion questions. We're going to talk about that particular journal article. Okay, so just to get you familiar and reading some journal articles. Again, we don't have a whole lot of time to focus on that stuff. I spend time talking about it in the regular semester. But summer semester, we don't have a whole lot of time. All right. So, and then if you look over here, I mean, obviously, as we get to like chance. So if we go to chapter 8. So there's a whole bunch of other videos here. So you'll see my YouTube videos, and these are what I did spring semester. Say they show up in the later chapters where this is the whole lecture. So I will be redoing a lot of the lecture videos. The are still in there. I'll probably do additional of these, but so you'll see this in the later chapters as YouTube videos that I did in there. All right. You guys will announcements. Again, Zoom section. Every meeting should show up in here. Again, each meeting should be in here. So forecast out and put some. Okay. Everything you need on the Canvas site when you're submitting assignments. So let's look at the lab thing. Again, we'll talk more about the lab later. Okay. We'll probably do lab stuff tomorrow, but all of the lab information for every one of the labs you need is in here. Okay. So if the documents, if there's a simulator in there, again, we'll talk about some of that. So there's a couple of these different labs. And then very down here at the bottom are the links that you would go to submit on the lab page. So doing the Penny Lab, you click on the Penny Lab here. You can also find it on the calendar that from the document. You just up like a attachment, right? And then it goes into the site, it pops up and tells me I got stuff to grade, and then go down through there and bam, 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 grade everything all at once. And so it makes it easy. Okay. Take a look at the lab stuff. Again, we'll talk more about the lab stuff probably tomorrow. Okay. so let's pause here. Did you have questions from the Canvas site? Anything else?
Will there be a study guide for the exams?
For the all right, so yes and no. So I do a review for each test. So a study guide as will spend some time doing a full review of all the points that you cover for the test when we get to it. The other thing here, let me bring up one of the other PowerPoints and I'll show you an example. Just one second. One of the other things that I do PowerPoints. This is the chapter 1 PowerPoint. If you do this, scroll down here to a slide. Important here. All right, so what you'll see slides as you go through them are in the corner. Okay, not a slide has a star on it, right? But there are some that, as they are starred, those are slides that. So that's kind of like if you pulled out like the 20 or so. I mean, there's slides in the first PowerPoint, but there's really only 20 of the star on it. So if we're building a study, you would pull out these particular slides that are starred at things that you would want to focus on. Okay, so when we're talking about, you know, chemical and changes, nothing starter. This is not really something to, or for like vocabulary rather than something I'm going to test you. Okay, and again, the learning objective. Okay, so there's a couple to enforce what the study guide really is. Okay, so it's not a formal out for you study guide. I've organized a way that if you put information together, it helps you to pick out what stuff is important. So each one of the objectives is starting, and the slides that there's a sign method, be able to differentiate terms of the sign and a down. So if we go down through this, you'll notice that there's with on it. Here's some and things like that. So you could pick out the important things out of that topic. Okay, and then we will do a session before the test. Okay, so that's about as much of an actual study guide. So it's not a study guide in the I've already prepared everything for you kind of feature.
Thank you.
Really, still? Hang on, I'm going to swap my ports here. Okay, how about now? Sound a little better? Yeah, so sorry, like I said, whether it's not a great microphone, I only bought the phone that I have because I had been planning on doing like some short videos on my learning objectives. I wasn't expecting that it was going to become like an absolute necessity for every day. I probably would have invested in a better microphone. Sorry about that. All right. So just be patient. I can. Okay. So if there's something that, if you let me up, doesn't penny lab. So let's take that real quick. Let me look at it from your perspective. Yeah, I mean, sometimes when I copy the course over, okay, I mean, it seems to work. You're talking about the Excel sheet? Oh, that seemed to download too. No content. Well, let's see. I'm in the student, so you should be. You guys, I'm saying what you guys see. So, usually there's usually a problem right here. Like I said, I can put it tomorrow and see if there's. Okay. Yeah, but I don't know. It's sometimes doesn't show up. But I think everybody. The first takeaway is everybody's got to be patient for the system. So it's, if it doesn't, just 5 minutes and try it again. There's nothing that is going to be super overly pressing that's wire up. Okay. So if there's something that's due and nothing is working, you don't need to panic. Okay. It's all online. Whether I get it at midnight or I get it at 6 a.m., I'm getting it right away at the next day anyway. So it's not going to bother me. Okay. So everyone, so I can, there's limitations on you guys. Sometimes the canvas doesn't work. Sometimes the page doesn't work. Sometimes it didn't download. My only recommendation for you guys is to be, number one, patient. Two, get things early. Okay, take a look at the stuff that you need to download. Take the web, if there's an assignment due, check out the website and download the document early, like the Excel sheet. So make sure does it pop in there? Because if it doesn't work, I can send you the copy of it if it really doesn't work. Okay. But if it doesn't work for you, it's likely it doesn't work for someone else. But you don't need to panic about anything. Okay. There's nothing. Okay. Even again, fix all that stuff. It's all virtual. We don't have to worry about deadlines that show up. Okay. So we're trying to keep deadlines, but it's not critical. Okay. So it's not the world if there's something that doesn't work. Okay. All right. So let's look at our PowerPoint here. Okay. All right. So we talked about the exams. These are the chapters that they cover. Okay. So first test, exam 1, is chapters 2, 3, and 4. Exam 2 is chapters 6 and 7, and 3 is just 8 and 9. Okay, with chapter 1 being a first. So the is mostly broken up so that most of it is chewable along the way. Okay, so 2, 3, and 4 are related to one another in a lot of ways. Okay, so 6 are kind of related a little bit. And then 8 and 9 are two different chapters, but these are the normal ones we cover together. All right. So we've been going for an hour. All right. So what I usually do now, what I would normally do if this class is to take probably a 5-minute break or a 10-minute break. Usually what I do when I do 10, where I lecture 15 minutes and take a 10-minute. Since everybody's probably comfortable, assume you all have a drink, not drinking already. We'll probably just keep pressing on, and you can just come back if you miss something, or come back if you need to take a break, if you feel to take a break. All right, so in studying chemistry, chemistry is the study of everything that's composed of matter, which, since everything is made up of matter, chemistry is really the study of everything. Okay, so matter, thing that occupies space or has mass. So this affects all aspects of our life, since everything has both mass and is made up of matter. All right, so early chemistry is derived. Early attempts at chemistry would be considered alchemy. So it's alchemy, not a science, how we think of science today. It incorporates some things that we use in science, things like observation, experimentation, but their goal is generally not the same as science. Not a goal of learning various phenomenon. Their goal was things like transmuting things into gold. They wanted to turn lead into gold and derive panacea or elixir of life. So while it's kind of, it wasn't their goal, but they weren't studying all these things. And so we had a lot of things that came up as byproducts. Obviously, if we're just randomly experimenting to change things from lead and gold, they obviously explored, understood things like metallurgy that are how we interact with various metals. Obviously, that's a byproduct of just messing with lead and gold and other metals is accidentally discovered very metal property. I also looked at things like basic soap lines, and again, these are processes that were just random out of the research that they were doing, but it was not the purpose of what they were trying to get at. Chemistry deals with a lot of different stuff, and it's much broader now than it probably ever has been in the past. And so looking at the condition structures and transformations of materials, when there are so many different materials, it really creates a very diverse science. So these two gentlemen here up again in the next chapter, and Lavoisier and John Dalton are considered the leaders. Antoine Lavoisier, who started most of this. I mean, he essentially coined out the law of conservation. He derived the law of conservation, and he wrote the first chemistry book. He covered a lot of the first elements, and he developed a lot of equipment to help him make some early measurement of basic fundamental properties. John Dalton did a lot of, all right. So, a little better. It tends to fluctuate, so it can go back and forth. I will, honestly, if we have this many with it, then I have to invest in getting him another microphone here. All right. As I was saying, Lavoisier is really kind of one of the important features. Talk about the conservation of man. he will show up again in the second chapter when we get to that. John Dalton essentially derived the basics of the atom, okay, our fundamental building. And so basics of the once we establish the basics of what the atom is, you have the basic proper chemistry. I mean, we have the atom, we have the fundamental building block, the Lego that we build everything from. So once we understand that, we have that, then we can, the other things are of those similar properties or parts. So modern chemistry bridges a whole bunch of things. There's computational chemistry, obviously pharmaceutical chemistry, forensics, polymers, all kinds of different things, all act as what we would call chemistry today. So our core chemistry are these over here. And okay, so these are considered our core: analytical, biochemistry, inorganic, physical, and organic. Right? But there are other kind of specialties that also see well, whether it's electrochemistry, environmental chemistry, polymers. Polymers are chemistry, but it's a specialization of organic chemistry. Pharmacology could be, a specialty of biochemistry or organic chemistry. Theoretical chemist could be probably some branch of physical chemistry. Same thing with nuclear is probably chemistry. And a whole bunch of specialties than a core area. So analytical chemistry is the study of the composition of matter. What's called analytical chemistry. Generally, what most people think of chemists, they generate the most amount of screenplay. Like if you watch CSI or any of the crime shows, these are generally the chemists with the tattoo piercings that are in some bottom basement place. They bring their stuff to. Okay, so ones with all the cool instruments do all the cool fancy stuff. So we see them a lot because they're the ones who are studying what stuff is made up of, and things like, how much is there? What is it and how? That's generally the focus of the analytical chemistry. So, and you want to know, poison is, that killed, petty officer so-and-so, the analytical chemist is the one who's going to inject it into his gene, and then it's spit out what it is. Work like that, but you get the idea. They're that we see from the TV shows the most. Chemistry process of the study of their living. So there are organic molecules, but they're also living. So there's the difference in chemistry from organic chemistry and biochemistry. So a lot of departments tend to be departments because biology and chemistry have merged so in the last decade. They've all become a joint group. To image thing has really boosted biochemistry. So our ability to look at real subject microscope, so things like MRI or MRI, we can look at the brain or brain while worrying about something. So they give a subject, eat a piece of candy while you're in, and in while eating it, they can see parts of the brain light up as a person enjoys eating candy. Here images, and we see over here, and parts light up when we look at images, and so study how one thinks or thinking while the person's actually doing it. They weren't really able to do a lot of that before. So as our technology pushes us forward, we're understand living process. And we see the thing with drug discovery when we do delivery, right? So if our drug want to target the liver, we can do animal studies where we look at the animal under an eye and use tagged agent and watch, see where it goes. So if we of our drug in the brain, what we're going for. If we're trying to liver cancer, liver. That's not help us if I have liver, right? So, if it all relates in the wrong spot, but we can actually watch that in real time nowadays with the tech we have as well, new imaging technology and different tagging things. So, biochemistry continues to be a very very important area of chemistry people spend time going into. University time, a lot of that. Inorganic chemistry, it's probably one people are probably not as familiar with. Most of the periodic table is up of metals. So inorganic, it's everything not carbon. And so there's a lot of things, ceramics. So it's ceramics are no just plates, and we use ceramics kinds of things, materials, breads and things are now material and metal. We can use everybody on these ceramic knives, so it never has to be sharpened. So are designed to a specific function that you don't need your knife to be made out of metal anymore because they are very brittle. Around, you don't really need them with any doing. We're not doing combat and then having to cut carrots, right? So the knives are designed for a specific and they do their very well. And so the things, official, pin things in the body. We want to design materials that back to our biology that are inert to our immune system. Okay. Organic chemistry is kind of one of those classes that it hates, thinks they hate at some point. You probably have to organic chemistry, unless you're this, then probably not. If you're a biologist, you're a chemist, most everybody else has to take some form of organic at some point. And so this study of carbon, okay? Carbon's most important elements. And so it makes up all the molecules we have in our body. And it makes up all the things that we do our body, and includes drugs and everything else. So it is a very as well that makes billions of molecules. It rather study in order to cover. And we'll talk about various aspects of organic chemistry throughout the course. And then physical chemistry is the area where we study mechanisms, how things do what they do, the rates at which things do things. So how fast do things. So we're not going to talk rates under called kinetics, which we would talk about on 12, and the of the systems. They want to model how exactly things do what they do. Okay, so generally physical chemistry is if you're good with computers, so the computer model, because a lot of the things in here are complex, knowing how a molecule maneuvers or how it binds to a molecule, and an enzyme lock onto its target, and then exactly how it does what it does, and design a molecule that fits in there, right? If it clamps like this versus this way, that makes a difference in its binding to its receptor, right? The telling how things do what they do take a lot of power. So a lot of with computers, chemistry, there's a lot of that technology. Now, on a regular semester, the new science is that I spend a little more on because I usually have people write a research paper. A research paper, which I usually have my regular semesters write a paper science topic. And so there's all kinds of new science that people to write papers on usually. In my regular class, 4 to 5 page research paper, and pick any kind of thing that they like, try to get people that they like, various kinds of things like micro cool that people work out, like the glucose monitor that's like on this, on their arm that they can put their phone to, and things like that. Those are utilizing microneedle technology to look of blood or fluid in order to measure glucose. The very patches that we for like drug delivery. Can we make a patch steadily disperses a like if you're taking antibiotics, like what if you could just put a patch on and that's your 10-day antibiotic, releases the antibiotic over the 10 days and you don't have to take pills and things like that. There's a whole use of micro technology. There's all kinds of photocell technology that various plants that all kinds of new polymers that are very lightweight, which allows us to reduce the power load on various things like robotics and prosthetics. There's some of our chemistry for things, contact lenses like that, like your, if you think of it like your we're able to pack a huge amount of information into that disk, and it's really material that's allowing for various layers of information to be populated. So they're looking at the same thing for a contact lens. Like, can you put your computer screen in a contact lens, and can we do where we just the eye, do many things like that. So there's all technology, but a lot of that is driven by the material. Computer science is virtual. Ones and zeros can be big or as small as you need. So it's really the material driver for computer technology to advance. Right. So why do we study? So help understand the world around us. We should be studying chemistry. Everyone should be studying science in general. Okay, it is a process for learning. Okay, the more informed society. So, in general, in fact, a more educated society uses less medical treatment, so their cost care, because people are more literate about how to take their medicines properly. They generally use things more often because prevention is always cheaper than treatment. Okay, but if we as a society are more educated about the things that we put into our body, identifying things specific for fiction, which is a huge issue, and it is a mental migraine for most scientists. Anything social media or just in general nowadays, if our people have resources, ability to understand basic science, everybody fits. Okay, you know, continue to press, and we see of things like people get taken advantage of for understanding, bleached thought, pure autism, and things like that. That is on all kinds of aspects. A big issue that most scientists include a lot of time with, not just in class. I mean, I'm here to teach is science. How can you determine what is pseudoscience? Okay, fake if you do basic science. And science is insidious. It's in its very design because they use words. They pretend scientific, the science method. So enough, if we don't engage our critical thinking on a regular basis, it is difficult to discern between fake science and real science, because it's like in a real way, in a way that it mimics very closely what it's trying to get at. Okay, so the it just right, but it's not a stick, right? And so, but its mimicry is palpable, and so it's very difficult to constantly be informed of things if we're not taking the time to constantly inform ourselves, right? So that's critical thinking has to become a part of what we do every day, right? And this is generally more of a things that we talk about during the regular, because we have more, right? And so usually some of this will come up at some point, all right? Whether we talk about, chelation or colloidal, pH diets. So the pH is something that comes up a lot. Really, when we get to 112, actually start. Now we'll talk about it in acids and bases. There's a lot of pH food people peddle, things like alkaline water. Like, how do you know that that's not that what alkaline is? So how can your money? So they're selling you something, but they don't actually either. They are using science to understand and then explaining to make fakes, and then if they sell it just like a product. And how do you know anything about the base? How do you know that it so we can understand where the fake science obviously we especially days of the next and things that is these there's a lot of science that people use in plants, right? And so it is more and more important that we take the time to learn about these rather than because otherwise we're taking advantage of, right? This helps for, in general, just to be informed citizens. I don't think there's any rational argument that can be made that being an informed citizen is not beneficial to it, right? So obviously we see all kinds of things in how we vote that affects our lives. So when we vote and people are in charge who think that genes cause autism, well, they make policies that affect that, right? They take garbage science like, they don't understand how climate change works. And then they don't take it seriously. They don't have policies that are necessary to deal with these subjects. And so if we as people are not educated enough in science, the things should be taking it, keeping up with, at the point like now, it's too late. By waiting longer, and we've waited to the point where no one wants to, and we have this whole more of a prolonged trend now of people who, we've disregarded science for, and made a cult of ignorance essentially now, where no one wants to listen to experts, and they put all these things on the side, and it affects people. We're talking about the lives of people. And so, as we go through this and we improve our critical thinking, even if you don't know anything in history, you don't remember any, the thinking skills that you get from science are beneficial to you on the road. Okay. Where we can make a better ourselves as consumers, right? So, consumers, we all buy stuff at the grocery store, but everybody will make better choices, but we have to be educated in order to make better choices, right? So, while you have the free choice, do that choice via our education. Okay, so if we don't understand the underlying issue, then how can we make a better choice for us, for our family, or for the next generation, right? So we're thinking, our energy system. At some point, probably this semester, but usually in my 112, you in it to talk about nuclear technology. Most people have never heard anything about technology. Some actual scientists to talk about how we need nuclear. Yet is fearing on Facebook and social media who don't have any type of degree in science, who are Google experts in, and doesn't any if that's the source to get your information from, right? And so about things like energy, EPA and things like that. There's reasons why these things are important. We need to put our vote to improve these things, right? And so I can give other like this, like how do we identify when science is bad? And you'll look at this one there to see a lot of we see out of every day. All you got to do is turn on the White House press thing, and you can get pretty much every single one of these. It's just a stupid on basis. And so you can see every single one of these things misrepresented, who's in charge of people, right? And so even it's important for us to make good decisions for ourselves, and recognize when we're being sold bad science. So, fake experts, whether there's, ticking of emission is a big thing. The anti-vaxxers like to concede theory, things like big pharma obviously out to get you because everybody's in big pharma. We don't, because they enjoy, not making money off of vaccines, so, there's kinds of these techniques used, it becomes it is a constant thing. We are inundated with this propaganda on scientists, okay, who understand science, who are constantly telling that science is wrong, or this or that, or don't believe these other people. And they don't use science. They don't care about what it has to say. Convenient for them. And so, at least a personal effort for ourselves. All right, so things that show up in the other lectures here, something you may want to do this in advance, but something that you may want to look into is everywhere. And I developed this together for, actually in class, it was kind of like getting everybody to work together. That one of the criticisms that I've in course evaluation in the past is, not getting people engaged in course, which again, it's not a philosophy class. It's a little hard to gather engaged. So it was a way that what you would see is this, right? And so you would get, and then you could log in to everywhere. Sorry, lost it here. Right, and so you log to the everywhere thing, and then your various responses. And so what I had to do was to have this be like, people would work together. We would take 5 minutes, work together as a group, and then answer a question. And you could kind of see this in real change through class. And so poll everywhere is everywhere is the site. You can get an app for your phone. You can get a computer. You can go to the website. And my room, Jensen 072. So time that a poll becomes active, it'll go bing. It shows they're in the app, and then you can do your vote, and so then it'll show up in there, and it'll show up in real time, and in real time as groups would interact and come, and then some people would one way, and then over time as we kind of just the numbers would change. Finally got on one of the answers. This is a tool that I had during the semester. Really, I had put it together more as a group activity that people would work together and kind of talk about it afterwards. So we can try and use it again. It doesn't get intended for being a group, but maybe the interaction if we're doing it. And again, it goes up percentage, doesn't put or anything on there, so you don't have to put any other information in there, and it's all anonymous. And you can do tap the poll, and it just shows up, and see everybody's real time. All right. If the audio cut out here and there, we'll take immediate try and a better microphone and see if that helps. I had for tonight. So I mean a lot of the information will be on the main page. So what I do is with post up the so that's pretty much all I have. And we can talk or talk. Oh, you don't need the poll today. I would look everywhere for tomorrow. I'll try and well, I don't really attendance per se. I mean, I wrote down as far as like when you like when you put iPhone. So you put your name down, then I will continue just your name down on my sheet and just kind of go with that. I don't have any. There's some other attendance metric. Well, no, probably not. We'll probably stop here. Like lots of so I'll probably actual chapter because we've gone, got a fair for I'm talk as fast as you, and I can also do the to catch up. Nothing needed per se. That if we run short on time, that we can't make up time elsewhere. So let's see. No, there's nothing this week. Do this. So it's just this video. Yeah, I'll post it up as an announcement. I'll put a poll everyone. So this guy is odd. He's months old, not even 6 months old yet. Handful. That's why we're up here, right? Because you're a bad boy. Mm-hmm. Yeah. So
nice dog. I like it.
He's a golden, and they're a handful when they're puppies. So I made it through the first class. Luckily the 5-year-old, at least he's probably being occupied downstairs. But between him and the puppy, it's like this. It's a constant cacophony of noise up here. So we're lucky if we can get through the class without too much noise. All right, so let's go ahead and call it quits for tonight.
No worries.
If you have questions around here, like I said, I kind of wrote down as you came in, so I'll try and match up something of a thing. But what I would recommend, put your name down when you sign in, and instead of going with a suit or letting your phone pick, and in that way I can write the name as our attendance, so to speak. Okay. And like I said, peruse over the chapter 1 stuff that's on the Canvas site. If there's stuff that's not working, or you're missing, or you don't understand, we'll come back tomorrow and we'll start on the real. We'll also probably talk some stuff tomorrow. Like I said, we got. All right. Yeah, there's nothing for tomorrow. You don't need anything for tomorrow. The pennies lab, right? Is that part of what I put? So all right. So then we'll talk about the penny lab. So we'll probably start off with some lab stuff. Start off with some labs before. And I can always push the deadline back. So I wouldn't much about it. We'll get to it all tomorrow. If the due drops or we get back a couple of days, I mean, you're get on, so we can back, push it back a little bit. Okay. So yeah, I'll post some announcements for the everywhere, so where you can get that, and we'll probably start with the lab con tomorrow, and then we'll start getting into that. I wrote everybody's name down when you came in, but I'm not calling attendance. I don't roll even when we're in class, because I don't want to end up in The Hague for a hate crime. So my of everyone's name would be horrendous. I have a phobia about calling roll, so I don't do it. So I just wrote everybody's name down. And usually I would just run a sheet and let you guys check off your own names. So I just wrote everybody's name down. Amen. What else? Everybody get into the Zoom, okay? Even if we were a little guess. So let me stop recording. Let's figure out how to stop. Okay.